Now see here spherical refracting surfaces here. If you take here like this is a sphere which is made of a transparent material and divide into two parts. This is the center of this. If you have taken one part like this, where this side is here the transparent material of some refractive index and this side is air. So now see here convex surface is facing here to air. This one is known as convex surface. If you are taking another surface like this, here this side is transparent material and this side is air, this one is known as concave surface. So here we will be doing now two types of refracting surfaces, one is a convex, another one is concave surfaces here. See here in both the cases we have to study the formation of the images and define the different terms like a pole, principal axis and center of curvature. So suppose you have taken convex surface like this side is transparent material of some refractive index and this side is air. First one, the midpoint of this surface is known as pole, that P stands for pole here. Center of this surface, actually that is the center of the sphere of which this surface is a part. This one is known as center of curvature. The line joining P and C, straight line joining this P and C is known as principal axis. Similarly, if you have taken concave surface in this way, so this one is known as the pole and this one is known as here, this side it is taken here center of curvature. So now we have to see the formation of images by these two surfaces, but see here there certain assumptions are made here. First one assumption is taken here, all these surfaces or the convex or concave has got a small aperture, angle of incidence and angle of refraction are small, and for getting the images only we consider here, we assume here the point sized object. So these are the three assumptions we make while doing the study of this one relation between the refractive index, radius of curvature and the object and image distances. And one is the sign convention also, as we have done in mirrors. All the distances are measured from the pole of the surfaces. Distances measured in the direction of the incident rays are taken as positive and opposite to the incident rays are taken as negative. Perpendicularly up to the principal axis taken as positive and downward to the principal axis are taken as negative. So these are the sign conventions and some assumptions for studying the relation between refractive index, object distance, image distance and radius of curvature.